Assalamualaikum and hi, my name is Putra Alisa binti Azmi and I would like to talk about an introduction. What is ascorbic acid? Ascorbic acid, or well known as AA, is a water-soluble substance which occurs in fruits and many vegetables. One form of ascorbic acid is known as vitamin C. The human disease caused by a deficiency of vitamin C is scurvy. The name is derived from scorbutus. Vitamin C cannot be synthesized by some mammalian groups of animals, including human beings, yet plays an important role in their metabolic processes. The next introduction is why it is important. For food, they are involved in the regeneration of tocopherol, and it is an anti-darkening substance in food because of its antioxidation properties. The next one is for human. They are collagen biosynthesis, ion absorption, and immune response activation, and is involved in wound healing and osteogenesis. Also, they act as a powerful antioxidant which helps fight against free radical induced diseases. Last but not least, for the plants, they are essential for photosynthetic activity during the detoxification of superoxide and hydrogen peroxide in chloroplast in the absence of catalysts. An objective for this topic is to determine vitamin C content in orange, watermelon, and cashew. The second one is using iodometric titration. And the last one is under different temperature conditions, which is refrigerated, room temperature, and heated.
Hi, Assalamualaikum. My name is Nadia Farhana, so I will explain about methodology. This includes method use, sample preparation, and titration procedure. For the method used, analytical titration is iodometric titration. Why? Because it is more suitable than acid-base titration, because ascorbic acid is a strong reducing agent that reacts specifically with iodine, providing accurate, sensitive, and interference predetermination of vitamin C in fruit juices. Next is sample preparation. Fruit used is orange, watermelon, and cashew. Temperature treatments is refrigerated for 24 hours, room temperature about 25 Celsius, and heated at 80 Celsius. And finally is titration procedure. First, fruit juices reacted with iodine. Second, excess iodine titrated with sodium thiosulfate. And lastly, color change indicates the endpoint. So next I will explain the sequence of reactions shown in this equation, which are commonly used in iodometric titration, especially for determining vitamin C. First reaction is iodate ions react with iodide ions in an acidic solution to produce iodine and water. In this reaction, iodate acts as oxidizing agent, while iodide is oxidized to iodine. This step generates iodine for the next reaction. Second reaction, ascorbic acid reacts with iodine. Ascorbic acid reduces iodine to iodide ions and is oxidized to dehydroascorbic acid. This reaction continues until all the vitamin C is used up. Third reaction, any excess iodine reacts with thiosulfate ions. Iodine is reduced into iodide ions, forming tetrathionate ions. This reaction is used in titration to measure iodine accurately.
Hi, my name is Aisha Nasrazrin and I will talk about the result of this experiment. As you can see in this result, we have three tables. Table number 1 is average titer value for blank and sample titration. Table number 2 is the actual volume of thiosulfate that observed in the mixture. And table number 3 is the ascorbic acid content of some tropical fruit samples that obtained by iodometric titrations. By this result, we find that cashew nuts have the highest vitamin C content, following by orange and watermelon. Cashew nuts also show the highest ascorbic acid content, while heating the fruits at 80 degrees Celsius resulted in the lowest vitamin C level. Next, the discussion of this experiment is the results showed that the cashew nuts contain the highest ascorbic acid content, followed by orange, while watermelon has the lowest. This difference is due to the natural vitamin C composition of each fruit. For all samples, Refrigerated fruits retain more ascorbic acid, whereas fruits heated at 80 degrees Celsius showed the lowest values. This occurs because of ascorbic acid is heat sensitive and easily oxidized. The higher temperature increased the oxidation of reactions, causing a reduction in vitamin C content. Refrigeration slows down these reactions and helps preserve ascorbic acid in fruits. Conclusion of this experiment is iodometric titration are the most elucidative, rapid, and easiest method for determining the ascorbic acid content of fruits. This makes it very straightforward for estimate the level of vitamin C and is useful in making recommendations regarding fruits to consume as a preventive measure against health problems that usually come with deficiencies. Regular consumption of fruits high in vitamin C is known to improve health and lower incidence of disease, known to cause diabetes, contribute glaucoma, atherosclerosis, stroke, heart disease, and even cancer. In this experiment, we learned that temperature affects vitamin C content, different fruit contain different amount of vitamin C, and ascorbic acid is heat sensitive and easily oxidized.